one. Thanks for coming, guys. I'll hand over to Roland. He's running the session. No, I don't think we've got mics.
Awesome. I'm going to speak as loud as I can. If it's a problem, just let me know. This will be good. This is quite an informal group, so I'll make it pretty informal as we go through. Do I need to hit record?
Already did.
Ah, awesome.
Live.
Live to the world, struggling as I go. Look, so thank you everyone for popping in today. What we're going to go through is a little bit on the fundamentals of React, because we've all been working with bits and pieces. You know, we've started building components as we go, and now it's a chance to kind of go back and kind of get an understanding of how our component structure, how that sort of evolves over time as we build more and more components into our system, and how this all works together within the React ecosystem with everything we built today and everything we want to focus on tomorrow. So we've got a couple of topics in this part one, which is primarily around component fundamentals, so understanding what we should be looking at for a component, what should we be putting in the components, what should the scope of the components be. Then we want to look into the lifecycle. The component lifecycle is a really critical sort of area when it comes to React components, because this lifecycle dictates everything from how a component is viewed, how a component updates, and how a component manages itself over time. Then we want to look at things like DOM manipulation. So those familiar with jQuery, the ability to append it to the DOM, well, React actually uses the concept of a shadow DOM, which is slightly different. So an in-memory DOM that gets punched out to the actual browser over time. Fourth, we're going to look at higher order components, which is the idea of taking a React component, doing something to it, and returning a brand new component. And the final one is just loading and managing data in our components over time. How do we pull data in? How do we pass data around? And how all that sort of comes and ties together. So there's a few things to kind of know when you're looking at React. It's a component-based system. So it's about these discrete building blocks that you kind of put together to create your application. If you think of your application as, you know, a game of Jenga, each of those individual pieces in a game of Jenga is one of our components, all built on top of each other, many on the same level, some underneath. It uses JSX, which is basically a way of merging JavaScript and HTML into the same interface. Now, a lot of people get a bit grumpy at this. They're like, you know, they should be very clearly extrapolated out from each other. But the more and more you use it, the more and more you see the control that you get with it, and it becomes a really easy way to sort of generate your code. And we have to use a transpilation process like Babel to actually turn this into ES5 sort of forms for browsers to make them sort of understand what's actually going on. Thing about casing, everything in React is camel cased. Everything from native DOM events, everything from every property. If you think about the way in HTML, you know, something like data attributes, or on a form you might have a label for. All of these have camel case variants, and this is to allow React to have its own event handlers that can kind of bind on top of the native browser ones. Really important thing to sort of remember when it comes to components is understanding the role of properties and state. So when we talk about properties, these are things that we pass into our components. You know, we pass them from a parent into our child. Now, these properties are immutable, and by immutable, they should not be changed. So it's really important to recognize that any properties that are passed to your component, the expectation is that these will never be changed over time. You can definitely construct new objects based on the properties that you pass, but you shouldn't be changing the properties object itself. The state is treated slightly different. If you think about it as the fact that properties you pass through to your component are the instantiators. These are things that are passed to that your component is based on. The state itself within your application component is about how your component evolves over time. So if you think about them in those two discrete use cases, one is for instantiation, one is for tracking over time, it makes it a bit clearer where we should be putting sort of variables and where we want to track them between our components. The other part, of course, is the idea of a shadow DOM or a virtual DOM. So when we look at everything that happens on the browser today, you see all these DOM elements output into the browser itself. You know, we can go into the console log and we can track through it all, but this is actually quite expensive. So the browser has to keep track of all of that, and it's actually not that optimal to keep changing all these DOM nodes, adding, removing, modifying. So what React does is it has this concept of shadow DOM, which is basically an in-memory representation of what the actual output of DOM is. Now what it'll do in the render process is it'll keep track in memory of what it thinks the DOM should look like, and then what it knows the DOM will look like. And if these things aren't changing, it won't make these expensive computation calls. It'll keep track of what's going on. And what it means is that we're only making changes when there's a difference between the shadow DOM and the actual DOM. So one of the big things when you're sort of building up components is we go down this path of everything's a component. I'm going to make a H tag, I'm going to make a component to wrap my H tag. I'm going to make an image, I'm going to wrap it in a component so I can do all the magic of React. But every time you wrap anything in the component lifecycle, you add extra complexity and computation requirements. So the question really becomes, do I actually need to make something a component? Is it more efficient and more isolated and more compartmentalized to just put the native DOM elements right where they are, or instead to return the values from a function, which is much faster than having to go through a lifecycle event series? So every time you're thinking about it, do we actually need lifecycle properties? Do we need to know that it's going to mount? Do we need to know that it's going to change? If it doesn't, we probably don't need a component. Do we need data? This is a really big key one, and it comes back to the idea of the properties being the immutable sort of instantiation blocks for our components. The properties we don't want changing, so where we store the data is really quite integral to the process. We want to store the data as high as possible where necessary, but as close as possible to the components that need them. So we want this ancestral idea of, if I load the data for, think of a nice use case, a to-do list. I might have a list of to-dos. I'll keep that as high as possible, but when I'm displaying a to-do, I want to pass it the exact reference of what it's working with, nothing else. I don't need to pass the full list of my to-dos when I'm rendering the to-do individually. I want to pass just the properties that are there. And that really comes down to, you know, this last point. What is the minimum amount of properties that I need to make my component work? The bigger the objects I pass into my components, the more memory it's going to take each time the component instantiates. Secondly, all the lifecycle events are going to trigger. They'll be looking at shallow and deep comparisons depending on how big these objects are. So we want to make sure that every time we pass a property to a component, it's required. If it's not, we should be stripping it out before we pass through to the component. So this is just a couple of diagrams to kind of highlight what the component lifecycle management sequence looks like. Now, if you have a look at the left-hand side, you'll see the very first one is component will receive props. Now, this is what happens when a component has been instantiated and the properties change. So we might have a parent component that has a value of, say, in the case of the to-do, we might change the value of the to-do from checked to unchecked. Now, if we're passing this through as a property, this component will receive props. We'll have a look at the previous properties and the current properties being passed and do an analysis to work out if anything's actually changing. And this lifecycle is really important because everything cascades down. So the second event you'll see in the left-hand list is should component update. And you'll notice that that's the first event in the middle list there. This is because properties and state both can dictate whether or not your component changes. So they share the life cycle together. The only difference being component will receive props is obviously exclusive to properties. So it goes down the path. It checks whether or not the component will receive properties, does a quick analysis and checks whether or not there's a change. It determines if the component should update. Do we actually need to continue down this lifecycle tree? We have an event to actually identify that the component will update to let us know, yes, a change is going to take place. Then we have our render function. This is the actual part where we compare the output of our shadow DOM and our physical DOM and see if there's anything going on there. And finally, component did update. A final event to say, yes, we did make a change to the DOM. This is where it's all come through. Now, on the far right-hand side, I've got 3 lifecycle events as well. Component will mount, component did mount, and component will unmount. Now these are quite important, and I've got a few notes in there. So component will mount is obviously what happens and is executed before your component does anything at all. It's being created, the constructor's called, okay, lifecycle is going to begin. So we're going to work out if we're actually going to mount our component on the DOM. So a big thing I really have here to note is that this function is called when doing server-side rendering. So if you're doing things on both the client and server, maybe loading some data from a third-party source, this is the place to put it there. The component did mount is called once a component has actually finished rendering. So it's after the component did update, but only on the very first instance. Now this is so that once our component is created, we actually have some DOM nodes in the DOM to actually work with. So this gives us a chance to say, hey, you know, we might have a library that needs a few divs to be available. Cool. We put them on the DOM. We can now let this library interact with it. And the final one is component will unmount. So this is what happens when you want to sort of detangle your component. Maybe you've set up some event listeners. Maybe you've got something that, for whatever reason, you put on some scope. Maybe you've even changed the Redux store or something like that. And what you can use is this unmount to do your cleanup process. Destroy your listeners, references, anything you might have in memory. This gives you an opportunity to do a clean cleanup at the end of that process. So the things to note, components will re-render every time the properties passed to them changes or the internal state of a component is modified. So if our parent passes new properties through to our component, or we change the state, so this .set state within our component itself, this is going to trigger that component lifecycle happening. If either the state or the props change, we've got to work out whether or not we're going to do anything. So this is again that component lifecycle opportunity. And you know, this gives us a chance to work out, do we actually need to keep updating? Are we pumping data through because it's changing? Is that data relevant to what we're displaying in our component? If you don't specify these lifecycle functions, React has its own internal calculations that go on for that. And you'll see I've got it in an attempt. And this is because it's a shallow compare. So I mentioned a bit earlier that it's really important to think about the structure of the properties that you're passing through to your component. If you make your properties really complex, big, deep nested objects, React actually, by default, will just say nothing's changed because your your root level properties on your object aren't changing. So you need to do a deep comparison, check every single value in those objects to work out if anything had actually changed, which is obviously a bit more expensive. So if there's no changes after all these processes, the virtual DOM and the physical DOM go, hey, nothing's changed, we're done. No expensive sort of CPU usage or browser usage while it's trying to update the DOM. Just says, hey, we're done, nothing to worry about. So I've got a question here. Obviously, what's the difference between shallow and deep comparison? Which does React use by default? And why does this matter? And I kind of just said it a bit there. Why is this so important? Anyone want to jump in? The reason it matters so much is the fact that inherently when we're consuming services, especially third-party services, we tend to get very complex nested objects. Now, because we don't know how big these objects might be, and we might not be controlling them, the last thing we want to do is force React or ourselves to start doing these really big, deep comparisons. So if you think about an object that's maybe property 1, property 2, property 3, and an array, that's very expensive to track down and have to iterate through the array to see if each of the options in that array have changed. So we really want to make sure that as much as possible, we're only doing shallow comparisons. That first level is the most critical level for our rendering process. We want it as flat as possible so that we can identify changes as easily as possible. So the more you kind of delve into React, you'll see there's a couple of different component types. So you've got, at the moment, stateful and stateless components. Stateful being the full React lifecycle, stateless being pretty basic sort of object, kind of a little wrapper with very little of the React logic in there. And you'll see there's this great myth that goes around that says that stateless components are significantly faster than stateful components to mount, unmount, and render. Now, this is a massive myth, and I'll explain why. Part of the reason it's such a myth is that we think that we're just returning basic functions. But the reality is, every time we instantiate any of the React lifecycle, we still have the initialization parts. Now, this is actually where React has been optimizing over the last couple of versions. But what it means is, one of the most expensive parts of the mounting process is still being run on a stateless component. So we think of stateless components as presentational components. No logic, just pass something, put it out on the screen. And it was introduced as a design pattern because Facebook identified that they wanted to change this over time to get some optimizations. So it has no smart logic. It basically, if anything changes inside your stateless component, it's going to re-render and it's going to run. But there's been a lot of changes. And in 15.3, we had pure components added in, which allows for one of the lifecycle events, should component update, to get you the option to have a shallow equal comparison on the props to control those updates. And they've done this intentionally because this is where you get the optimizations. They can take away a lot of the instantiation process and focus on the updating process. But of course the question comes down, knowing all of this, knowing there are some myths around there, should I use stateless components where possible? Definitely. Because they're easier to write, they're easier to read. They don't have any abstract logic sort of bundled into it. Basically, they're a function that returns some JSX at the end of the day. The thing is, there's heaps of performance improvements that are coming for these stateless objects. So that's why the design pattern is so important. It's not so much for the optimization today, it's setting you up for the optimizations in the future. And that's why I think personally they're really important to have in your components where possible. But you need to identify that your components can survive without needing any of the life cycle. You need to know that if something changes, your component should update. If something needs to be mindful of the fact that there's going to be a lot of evolution over time with what it's passed, it's probably safer to put it in a stable component. So I've also put a little optimization in here. So I mentioned that it's a myth that it's not as fast. And again, that has to do with the build-up of the component itself. But what if we called our stateless component as a pure function instead of a React component? We'd actually run none of that logic by default. And because our stateless components are essentially presentation components, they actually don't need to run any of the React code. So as a quick little sort of trick, if you're going for base optimizations, you can actually wrap it as a function where you just pass the params instead of using the React mounting sort of idea. And you'll get a huge improvement. I think some of the numbers I saw with a few of the guys who were looking at it were about 40 or 50% in terms of your mount speed. Obvious caveat, every time anything changes, it's going to rerun. So you want to keep your components as simple as possible to take advantage of this. Last part before we kind of jump into a little bit of the code is understanding about DOM manipulation. So we're all used to the idea of using jQuery and document.getElement by ID selectors to work out where things are in our components. So what React does is it has this concept of references, which it uses to interact with its own shadow and physical DOM. So when you specify a DOM element, you can actually attach a ref parameter onto it and provide a function to it, which will receive a direct literal HTML entity reference that can then be passed to a function. So you can keep tabs on these individual references. I've got the Facebook example code on the right-hand side there, where you can see in the return statement, the input object, the ref is passed a function, takes the input, and then binds it into the component. And this way we've got direct access to the component over time. We can make changes really easily. There's a few use cases for when we want to have these refs, and especially for things like forms, where we want to get the direct values of forms, modifying the browser view scope. So if we want to scroll the browser up and down, we want to scroll to a particular element, we definitely want to have the references. And I know it's horrible to say this, but third-party UI libraries like jQuery, they require our ability to do this, to interact correctly. It's just a pure low-level element, low-level JavaScript at the end of the day. And I do want to really give this caveat. I do not really encourage jQuery in React components. There are use cases for it though. I mean, those using Bootstrap with React, you've got to have jQuery to work with Bootstrap. But if you have a look at something like ReactStrap is a good example of this. They actually handle all these bindings and unbindings with the ref nodes to ensure that jQuery doesn't actually modify your DOM for you over time. So I want to talk a bit about higher order functions. I just want to make sure this seems to have taken out my entertainment pieces. That's all right. So I'm going to jump back here really quickly and jump into a bit of code. And what I want to show off here is this little React learning kit I put together. It's just on the top of a library I really like called React Go. Just makes it easy to jump up and get started. And I want to talk about things like the React component lifecycle management. And I want you to have a look in the console I've got here. Let me know if you can't see everything. I'm just going to reload the page. And what you can see is I've got beginning the component mount sequence, the component has mounted, starting the component lifecycle, checking whether or not props have been passed in, checking if we should update, checking if there's a difference in our properties. And you can see now it's going to iteratively go through this whole lifecycle every time the property is being passed or changed. And if you have a look, you'll see the page is updating every time anything changes. And you'll see it keeps going through this lifecycle process. And you'll see the messages, since the data has not changed, it all sort of keeps tabs on it. But we also have confirmations of when the name generated is identical to the previous name. So we stop going through the component lifecycle. So this just sits here on a 5-second loop, just going through, changing the properties that are passed through to this component. And all it's doing is just tracking through the lifecycle step by step. And the lifecycle looks just like this. You'll see the very first part. Can everyone see this okay? Great. I might make it a little bit bigger just in case. I can't really see, but that's all right. I'm going to step through this sort of one by one. First step, component will mount. We saw that was the very first output line in the console log. The second step, component did mount. We saw that was the second line. And this is where we're highlighting that the DOM has been rendered onto the page. Next, we're going to start the lifecycle on the component will receive props. So we see that we've got a bit of a dashed line to highlight. And we'll see that what we're doing here is when these properties come in, we are taking the properties that are passed through and attaching them to the state. Now, the reason we're attaching them to the state is so that we can track the previous names that are passed through. And this way we get a baseline preference to come through. And this is a really important concept in terms of what data we want to have in our state versus what's coming through in the properties. We want our component to be self-aware. So our component, we don't want to have to pass it through the previous property and the current property because the two don't relate. These are very specific use case to our component working as it does. So we want to use our component to control that. The component itself becomes responsible for managing what data it accepts and what it does with that data going out. So you'll see here in should component update, it checks whether or not the properties have changed. And you'll see I've got a little next props.firstName equals this props.firstName. So we're checking whether or not the properties coming through are changing. And since it hasn't changed, we don't want to trigger down the lifecycle. We've got the component will update component, but we are going to update this component. And you can see this is only called if there is a return true from should component update. And so this is just a way of demonstrating that you can control how much of that lifecycle you go down, depending on what data you want to work with. So you can see this will just keep running. With any luck, we'll get a nice collision soon where the names match the previous name in there. There we go, double mic. And I'm just going to highlight here the third line. Since the data has not changed, we do not want to continue down the lifecycle versus confirming we are updating the component. And you'll see there are extra steps that it has to take afterwards. So you can see we can cut that process out of there. So I'm just going to jump back in here. So what's a higher order component? Anyone want to take a stab? I've got a pretty outlined version up there, but I'm going to articulate a little bit. A higher order component is a way of taking a component, passing it to some function, and then returning a brand new component. So we extend or wrap our existing component with additional functionality. So what can we achieve? We definitely get code reuse. If we know in the case of things like any use case we have that we need to add some binders for certain event listeners, we might want to share access to a store of data. We might want to change the state or properties to reference something outside the scope. We might want to be listening to events or a data store and see if anything's changing in that and punching it into each of our child components. So it gives us this flexibility to extend and control components with a shared mechanism. And I'll go into detail in this just after. I'll go through a few examples. There's some really popular examples of higher order components, and probably one of the most well-known ones is connect, which comes from Redux. And what this connect function does is it takes your component and it takes a couple of properties, and what it'll do is listen for the properties mentioned, and if there's a change, it will inject them as brand new properties into your component. So instead of us having to write all these binders to Redux to go, okay, I want to listen to this store and this store and this store and reducer, we can just do it all in one place and centrally grab out the values that matter to us. And a Redux form is another example, which adds Redux listeners and component watchers. So we can listen to every event that takes place in a child component just by adding and extending it as we instantiate. There are two very sort of primary ways of doing this. The first one, which is properties proxy. So this is the idea of manipulating the properties that we pass through. Maybe we have a shared property we want to store in a high-level state and pass through to each of the child components. It gives us an opportunity to access the instance by the references and scope, so we can pass back some of the child nodes into the parent node by doing two-way bindings there. We can abstract the state away from the component, so we can have one component which manages the state, and then lots of little stateless components underneath that let the parent control the data being passed through. And finally, it's a way to wrap the component with other elements. You can add new styles. For those familiar with, say, Bootstrap, doing like a Bootstrap inline form, you do a div form group, you then do a label, you then do your div field to sort of identify where that's going, and then you close it. But you could just have a wrapper that you pass in an object that contained your input component and a label, and then you could use this props proxy to sort of wrap everything that comes back to add those extra HTML nodes. The second example is inheritance inversion, which is about extending the wrapped component functions, but allowing them to be accessed from within the child component. So actually passing accesses from the parent into the child. So making the child aware of the parent outside it. And it gives you an opportunity to hijack the rendered output as well. So you can take the output of a component and say, this is awesome, but I'm going to add a few more classes here just because I know my parent has that. So you can see that I've got a onChange example on the right-hand side, and my wrap component takes the original properties and new extended properties. So I'm going to use this as an opportunity to jump back. And one of the easiest ways I've found to explain higher order components is to think about a form. So here I've got a form, two fields with labels. and I've got a value 1 and a value 2. Now, in taking a few steps back, I mentioned it's really important to think about what properties you're passing through to your components and whether or not they actually matter to the components themselves. Now, if we take that same mindset and think my higher order component should only be concerned with certain things about the child, we can start adding extra functionality and make our parent component very aware of things that are going on in its child. So what I can actually really easily do is keep track of the value changing over time. And importantly, because my parent always knows what the initial values were because it instantiated it, it means if I change the value back to the original, I can keep track of that original value and the new value separately. My component itself has no idea whether or not the value's changed. It's just outputting it as per normal, but my higher order component knows that it's changed and changes the output of that component over time. And the way we achieve this you can see here a very, very basic example, so please forgive me with this, that I have these field objects that I've just put in that are wrapped in here, and all I'm doing is making a very basic sort of way of passing these fields through an input component, and I'm using a fake store to pick up data going around the loop. And what happens in my actual input component is here I have the field. The field component we mentioned earlier. I'm using that Bootstrap example again of wrapping all the required Bootstrap classes. So I've got the form group, a row, and you can see I'm checking whether or not the field itself has changed, not the input component. I'm checking if the field has changed. And then my input component is just being referenced with whatever properties were passed through, the current state value, and then passed through a shared onUpdateValue function. And it's using this onUpdateValue function that I'm just using my fake store and tracking whether or not at that higher level the input component has changed. Again, the input component has no idea that anything's changing in the values it has from its original values to its current values. It's responsible purely for outputting what the current state of the component is. But our higher order field is tracking all of this. So it's extended the input component to get these features by wrapping them in a new function. And you can see I just have simple hasChanged functions where I just check the state, saying yes, something has changed over time, and checking whether or not the values have changed over time as well. So a flag to say that it's changed, and then I'm using it to also check how it's changed. And this is how I'm able to check the original value and roll back without anything having to be done at that lower level. Very, very close. Next, I kind of want to jump a little bit into data management and loading and managing data in components. So, properties of data that is passed to your component from elsewhere. State is for data that is specific to your component, and I keep drilling this home because it's really an important way of visualizing what your component should be thinking about. All its state should ever be worried about is exclusively to what is being rendered by that controlling state. So when we want to load data in, and we're building our components, we're going to load data from an API, we should be asking ourselves quite a few questions. We should be sitting there going, So we need to ask ourselves a question of reusability. How many other components will need access to this data? If we're going to share data between multiple components, it makes sense to make sure that each of those components is not loading the data independently of the others. So we want to have a single source of truth for our components. And this means we might want to consider lifting the state up, which is where you kind of want to move all your data storage to the closest ancestor to where your component is using that data. Now, do I need to access data from an external API? Can I load it somewhere and just access it directly? And if I do load data from an external API, how do I track if the request has been made? So how do I track if I've initiated the request? How do I track whether or not the request was a success? How do I track globally or even component-based whether or not that request was a success? Was a success? So when you're thinking about this lifecycle of where I'm going to initiate data, there are kind of two key lifecycle methods that are recommended to kind of initiate it. And these are component did mount and component did update. And this is because they're aware of properties being changed in props and state. And what it means is you can load your properties in. If you're going to load your properties, instantiate them in state, store them back directly, you don't want them to keep triggering every time you change one value, everything else. You want to catch it at the last point and then rerun your verification down the pipeline. There we go. I was wondering where I put these. So the first one here was obviously that lifecycle demonstration I just did at the beginning, which is about tracking each of those steps, making sure we see how that lifecycle evolves over time. So we can do a couple of tasks together here. A few really fun ones to do is putting a notification on the screen to identify that the same name has been picked twice in a row. And the second one is to count how many times each name is displayed, put them in a table, and keep those counters incrementing, and how to make sure that that isn't going to impact on other components in the list. So that's one task we can work on together now. The second is switching to a higher order components where we can actually, let's look at adding new field types. Maybe we want to have select or checkboxes, which are a little bit more advanced than an input box, because in the case of, say, a checkbox, we need to track the checked property. So we need to make sure that this is going to come through. Select boxes, we need to track the list of options and track the actual value to make sure we get the selected property correct. We can also look at adding error handling to the form. So required fields, numeric is email. We might have some custom logic that's being done there, and ensure that they add the bootstrap error classes to the form group. And the final one is form submission, and ensure that there's no errors on the form. So not only do we want to check at the component level that we've got things going on, but we want to have our parent know that the data that's coming through is valid at the end of it. And the final set of bit of work we can do today is a bit of data management. So this is the idea of selecting a bit of data that comes through, and we want to go through what's in there, see what's coming out. I'm just going to jump over here, go to the home page, and hit the loading data into your component. If you'll excuse me, you'll see I've got a gigantic list of names. This is just generated on the server side, a completely random list of names using chance. Every time I reload, brand new set of names. But as you can see, I've got a fair bit of data that's come through here. I think I've got about 105 records from memory. So what would be good to do is we want to paginate this list of records, and we know that we get everything back from the server in one chunk. It's a very basic server. We're not going to do any back end for this right now, but we want to paginate this so that we only get 10 per page. We want to be able to keep track of the current page in the search results, and we want to apply a bit of filtering. We want to be able to iterate through and make sure that if I type in a name, only those with a matching name will be matched as it comes through. So my question to you, each of these three demonstrations, which one would you like to start on?
Table.
Sorry, mate?
Table.
The table? Data management. Okay, this will be fun. So, who wants to have a stab at getting started with this? What are the first things we want to think about and consider when we're talking about the pagination? So I'll jump over to the code and we'll have a look together, and we'll step through this together, and we can see what ways we can look at doing this. So having a look at what I've got here, if you have access to the code, you want to look for the data management container under containers. the actual file location just visible here. App containers data management. And we'll step through this together and we'll go through the logical steps that we're taking. I have actually set it up to give you a quick pagination start there, which is very intentionally not showing, just to get people on the starting path. So once everyone's got access to that and wants to go, we're going to start stepping through this step by step. You'll see in my component did mount, I've called my learning service user list, and I just store the entire list, 105 records, in my top level state. And two things to note, I have a list item down the bottom here. I'm not actually iterating over the state object directly. I'm actually having another component manage the output. Now this is a way of separating the concerns. I don't want to muddy the waters with my data management component by worrying about how to output everything. I want this literally just worried about getting the data and passing it through, nothing else. Everyone okay with that size on the screen up there? Great. So we're going to get started. So the first thing we're going to have a look at is these three values: items, page, and pages. So what I'm doing is I'm pulling these out of the state. Now the state, when I instantiated the object, you can see that items is an array. You can see that page is set to 1, and we can see that pages is set to 1 as well. So the current page and the amount of pages. So for those familiar with sort of pagination patterns, we've got 105 records. What's the first thing we probably want to do going forward? 105 records displayed in the list. What's the first thing we want to do? Anyone?
Decide on how many items per page.
That's it. Decide on our first visual limit. So we want to probably have something in our state that identifies what this visual limit is, because it relates exclusively to how this is going to be used. I'll just call it per page. Let's call it 10. This way we now have all available throughout our component, a value that we could potentially change over time. We might want to make it 20, we might want to make it 30, but we can give the user this option by using the state as a way to control this. So we now know how many items per page we want to have. So, once we've loaded our data, the first thing we need to do is, probably before outputting it, work out how we're going to filter this set down to our amount of items we want to have visible. So we want to find a way to visually show this at 10. So we might want to add a new function because it relates exclusively to this. We don't want to muddy our render function where possible. So what we want to do is, we'll call it pick, we'll keep it very simple, pick rows. Now what we're going to pass it, absolutely nothing, because we're going to take advantage of these state objects to filter out what's there and pass them through to be represented. So what we're going to do is we're going to take items out of our render function because we don't necessarily need it, and we want to make it pull from the pick rows function. So we need to do our logic. We need to break down the amount of items there, and we need to group it together logically. So the first thing we want to have is we want to know what page we're on. So we've probably got to keep tabs on that. We also know that what page we are on times by however many rows per page will tell us what the offset we have to do inside our array is. So let's start by picking that first offset. So you can see I've taken this.state.page minus 1. Of course, the reason being 1 is not the very first index in an array. 0 is actually the first index. So now that we know our offset and we know our limit, we can use this to generate a start number and our end number for the array. Now the start number is going to be the offset, and the end number is going to be the offset plus the limit. No, I could probably just return this directly pretty safely. Now, of course, I've got this acting up at me. I'll do it the old-fashioned way. Sort my bindings. Does anyone understand why I've added a binding to this in the constructor? It's because we want to be accessing the scope directly at the component level. View items is not defined. And there we go. We've now got the first 10 items displayed on a page. And you can see the IDs correlate that we've got the first 10 items. 1 to 10 is displayed. So we know that we're starting at the very beginning. The next step we want to take is to actually add some pagination buttons. Always lots of fun. So let's have a look. We know that this pages needs to be updated to reflect how many items have come back from our API. So what we can do is actually at the same time as we're storing the items in the array, we can set the pages to be request.data.userslist divided by this.state per page. Better yet, I can make it nicer, access the current or the previous state or current. And now I have an option of making this account for the fact that there might be a bit of a mathematical anomaly. We know that if we have pagination involved, you need to go to a ceiling if you have any remainders. So we now know that that's all up and running. And just to make sure that we're feeling comfortable in our render function, let's have a look at let's just have a look at our console, make sure everything's okay. So we've only got one page, well, pages has come through as 1. So I should probably have a look here and make sure I haven't done anything silly. Have to apologize, kind of doing it on the fly, always a bit risk and reward. Anyone see what I did wrong here? Yeah. Should probably keep tabs on the actual counter there. And you can see how many pages? 11. Which is great because we know we have 105 records, so this gives us a means of calculating that. So this also means I have my little pagination object now displaying at the bottom. Now we need to make something a bit nicer. We need to make something that's going to account for what's in there. So let's give our pagination function the ability to change page. Let's make a function to go to the next page. this. And we know that our next page function will need to take into account the current page and increment it. We can do the exact same logic for previous page. And we can step along together with this. And so we've now got a function that'll iterate next and iterate previous. And we've got a pagination where we're keeping track of the page and the pages. And what we can do is add a go-to page. We'll give it a default value. So we've got this means now to pass these around, and we want to give our pagination knowledge of these functions. So we can add and you can see I'm passing a function from my parent into a child component. So what this means is my pagination component is going to have access to calling these functions in my parent, even though it has no direct knowledge of how that actually works. So let's go up and have a look at our little pagination component. And you can see it does its own test. If page is 1 and pages is equal to 1, it's not going to display, which is handy. But we need to put some items on the page. So maybe we want to start with the first page. And we'll make this kind of look as nice as we can. Make it small, wrap it. We'll keep it very basic for now. We'll just add previous and next. Sorry for the typing. So we should hopefully have a bit of a nicer, whoops. Again, you'll notice the uppercasing is required. And now I've got previous and next abilities with my buttons. I can make this a bit nicer and text right, text left. So we want to trigger the on-click event, and we know we've got some properties we pass through to go to next and previous pages. So what we should do is take these right out of the properties and we can actually bind them onto the button itself. Oops, that's a great page. So we've got some functions in here. So we need to make sure that these are going to work and make sure they're firing. Let's just make sure that they're actually being called. Okay, so I'm messing things up. There we go. So you'll see that it's now iterating and updating our data. And it's doing it only at that component level, because that's the only part that we have to worry about in our page. I might shrink this a little bit just so everyone can see it on the page. Is that okay for everyone? So you can see we've now got the ability to paginate through just by making two separate components that are only concerned with their specific use case. One is only concerned with data, and one is only concerned with rendering buttons. But both can use that parent, that higher order idea, not fully, but that parent component to pass through the options that it can interact with over time. So that way we get something that very quickly paginates through and is only updating, this middle area here. Nothing else is being updated, just the component itself that was being updated. So in keeping with our track, we now want to probably show the current page on our search list as well, because knowing what the ID is doesn't necessarily tell us what page we're on. So let's quickly add our current page somewhere on the list. So we've got our data management, and what we can do is just put the current page and append him instantly at the end. And this will keep track of where we're at and make it very visually easy to filter. The last one we want to do really quickly with this is filtering. On-demand filtering, using a text box, tracking the fact that it's going to change over time, and then repeatedly, and then recursively going through our array, doing a little bit of comparison, filtering where the matches, and coming back with our new results. So how do we do this with the fact that our pick rows is now defined? Well, we need to extend this function to be aware of the fact that there might be some content we have to deal with. And so the way we want to do this is we want to add a reference to our filter. And what I'm going to do is bind it into our component, into a property in our component, so I can access it from within my other functions. We're going to make it this dot so what's going to happen is there's now this scope will have access to this HTML filter node. And what we'll do is we'll show him in the pick rows object. So just for the visual side of things, just going to scroll this up. You can see I've got a full access to the HTML entity as if I'd used document.getElement by ID. This has been made available back into my application scope. And now because I have that, we can now work out how to track these different changes that are going to come through. So this gives me access to it into this filter node, and so I can check the value of this over time. But this function isn't going to run unless that value changes. So I need to be keeping track now of the fact that these filter values are going to change. So instead of leveraging this filter node and accessing it directly, what I might do is every time it changes on this, I can run a new command to re-trigger and reset the state. So I could have this update the state. Do we think state's a good place to store the filter object? Well, here's the magic question. The text I'm going to type into the filter field, does this change the way my component is going to function? Time to start nodding. I say nodding, which is good. Yes. So we probably do want it in our state, because this lets us know why the component is behaving the way it is. So we want to have probably an onUpdate or onChange sort of filter here. So we can keep tabs on that there, not necessary, but we can add we could add on keyUp, which is probably the most suitable one here. And I'm going to add a new function called change filter. Sorry if it's not 100% visible to everyone. I'm going to set my filter to empty. That's going to be our default starting state. And every time it changes, I want my filter to run. We just want to pick this up every time it runs. We're not going to do anything straight away. We're going to keep it as simple as possible. Value of undefined. I remember how E is going to look. My apologies. Pick rows is, whoops. Skew, whoops. Just go here, that's all right. Left this comment in before. You can see it's saying -1 as a starting page. We haven't quite validated that. And you can see that this is, the console is being called every time I change the text. So this is our opportunity to trigger these re-renders. So let's jump back into the code. We know that pick rows, we want to see if we have a filter. To be very more specific, so you can see I'm just doing 2 tests. Again, I'm just making sure that the values in there make sense. I'm making sure not null or length is greater. And what I'm going to do is I'm actually going to make a copy of this items object here. And the reason I'm going to make a copy of it is that we have to run 2 filter passes. One is to filter down the original list of items to only those with our text. The second is then we have to add our pagination logic. So we want to have it passing through 2 phases. So now that we have our items list tracked together, we know that we can start filtering this down in phases. If we have a filter present, we need to then run an array filter component. Oh, I've got to remember how to do this. Filter syntax. We can do a little bit of regex here to make it a bit nice. So the only way it will be included is if it matches our filter state. So we need to do, we'll just add our filter, make it case insensitive, global just for the sake, and we'll test it on, we'll just do the first name. And excuse me for 1 minute, I just have to remember what the field actually is. First underscore name, great. So I'm just going to check the first name for now. So again, because it's state and state is tracked, let's see what happens. Not much. So I'm obviously failing very bad at my filtering command. Anyone remember the signature for doing filter on arrays? Having a blank moment. Sorry. You think correct? Well, let's see if I. See if my if condition run. Can anyone guess why it's not working? Should probably update my state to reflect the new value. Just reload to the stable track. This is where it's getting a bit caught. You'll see I'm getting caught with the updates. Can I read property value? Oh, no. Well, let's just have a look here. We're setting the state here preemptively. My screen just turned off. All good. Setting the value preemptively when there's no value in there. So we might want to just do a quick check here. H. Cannot read the property p.target.value. That's deciding to act up on me, isn't it? This is why. There are better ways to do this. I'm just doing this as a quick little work through, so I do apologize. There we go. So you can see it's running through everything incrementally. Take out a horrible filter and a few of our console log lines. We'll just reload again so we get a nice big list of content. And you can see that we maintain our pagination, all persisted within the state and all wrapped in that same component. So that kind of wraps up that idea of sort of, using a parent component, looking at the state, making the state aware of only the component that it needs to be, and tracking how that evolves over time. And that's why it's so important when you're looking at properties in state and thinking about what events and what things do I need to track in my state. It's about those things that actually impact on the output of your component. So you need to think very clearly every time you're trying to bundle everything together, and think of exactly what I need to store, how it's going to come together and be used within my component, but importantly, how it's going to be reused by other components possibly underneath. Does anyone have any questions at the moment? I hope that was clear, kind of going through that, why it worked, why I had to add those event filters, why I used the state to track the filter text so I can keep tabs on that over time, why there was a separate list object and pagination object. Again, separation of concerns. We use components that behave based on the properties that they are parsed. I'm going to bound that up there. Any other questions from anyone? Anything we've gone through? Anything you want me to go through again? Or we can go back through some of the workcourses we have there for the other components. We could look at the forms. Hey.
How do you normally run unit tests against?
How do I normally
run unit tests against?
Sorry, definitely post.
Run unit tests.
How do I normally run unit tests?
Against components.
So for components, especially for things with state and using things like jest, as in terms of a mocking framework, you'd actually be using the call sort of lifecycle events. So what you can do in Jest is you can inspect the properties of the object at a given point in time, and you can check the state at a given point in time. So within your component itself, when you're writing, say, a Jest test, what you can do is actually say, hey, I'm going to simulate a click here, input here, a click here, and maybe some more input here. And then I can keep inspecting the state of my component to know whether or not it's behaving the way I expect. So for a unit test, I'd be looking at that sort of state level sort of outputs and tracking how it evolves over time. And that, of course, makes the state so much more critical, because the state should reflect how your component is evolving. And then you can use that state and line up with the output after each of those events, check whether or not, for our list of names, we can check whether or not the filter is actually filtering each of those rows by those that had a matching text. We could check the amount of rows that match and confirm that the output did, say, 8 rows that match the word milk versus 8 rows when we do it outside. So we can use those sort of ideas of checking the state as a master and then binding what we expect it to be on the side as well. So I guess the best way to articulate it is, whatever you write your test to do, you should be able to confirm externally to your component. So your component should have state that confirms it, but you should be using something to calculate what is expected out of it. I hope that helps. Hey.
And the pagination of component can be used as a stateless.
Say that again, sorry.
For example, I saw that pagination is the component.
Yep.
So my question is, can it be stateless component?
It certainly can. It definitely can. There's actually no reason at all for having that to be a stateful component. There's no state management or anything in there, which is perfect. That's actually one of the questions I was hoping to get. Why is it a stateful component? There is no reason. It should be a stateless component because there's no logic. Do you want me to show you how to turn that into a stateless component? Wonderful. Let's jump back. So let's find our component, pagination. Now we want to make them a nice, simple, stateless component, basically a functional wrapper. So let's have a look at what our expected output is. And let's have a look at what variables we care about. So we know that there are these 4 values we have to get that come from our component. So I'm just going to write it underneath here. And I can make it even easier. I won't do any logic. I'll actually return just the rendered output. And I'll just uncomment all of this. Make this look a little bit nicer. And let's jump back to our page and reload. And it's having a go at me, and I think it's because I did there we go. So you can see just that shift. Do you see I've got, it opens up into a function that accepts an object with some properties, because React passes everything through as an object list. And then all I've done is the return object for the sort of self-functions is I can return whatever the output is. So I've wrapped it in the render sort of brackets, and this way it just outputs it straight away. So you can see the difference in code is very minimal in the output, but it just means you don't have a lot of those access to the lifecycle events. You can't instantiate or look at anything like that. Do I think this is a much better way to do pagination? 100%. it's definitely the right way to do it. Because there's no business logic or any logic at all. It's pure output based on what's passed. Anything else? Hey.
Recently, WordPress, Apache, and Chinese IT company Baidu decide to stop using React. How do you think about the React license? Is there any concern in our company?
I'm not going to go too much into that because there's a fair bit of legal sort of umming and ahhing over that one. It's probably not an easy one to talk about. This is something that...
YouTube too, don't forget.
Sorry?
We'll be posting this on YouTube.
I know, which is why I'm not commenting. But after I'll give you my opinion. Anything else from anyone? Awesome. Well, look, thank you very much, everyone, for coming up today. I hope that kind of gave you a bit of a sort of a base, fundamental sort of run through about the way certain things work and why they work in React. And if there are any questions, please come and grab me. But importantly, there is a part 2 of this, which goes to the opposite end of the spectrum, which was actually last night, which actually covers things like use of Redux, routing, server-side rendering, jest and unit testing, and how that can be used and bundled together. So please have a look on that. You'll see the video for it last night. I was a bit loaded on pizza, so hopefully I sounded better than I do right now. Awesome. Thanks everyone.